Hello, welcome to the show. It's me, John Park. It's time for John Park's Workshop. You are here, and so am I. Thank you, everyone, for stopping by. We've got our YouTube chat and our Discord chat happening, so if you're somewhere else and wondering where the chat is, this is a good place to check over here, particularly, and that's accessible by heading over to adafruit.it/Discord. That's the short URL for it. And then head on over to the live broadcast chat channel. And there's plenty of other channels where lots of chat is happening all the time, but this is the one that's going on during the show that I'm keeping an eye on. So thank you everyone for stopping by, all you good people. And let's get on with it. So let's see. First of all, I was able to do a bunch of maintenance on this very machine, this computer right here, last week after the show, and so I think some things are working better, including the Python install that was necessary for Disco Tool. So I'll be able to show Disco Tool in action during a pre-recorded CircuitPython parsec today. I recorded it after I got things working last week. Let's see, we'll do a little bit of a jobs board, some product pick of the week, and then we'll get into some project action. As you can see from the little description there, this is a Pico step switch party. So I have a few different things I'm doing. I want to show you these cool little switches and some ideas for some projects to do with them. And I guess that's it. So let's get going. So first of all, as I said, we have a jobs board over at jobs.adafruit.com. Head on over there and you'll see this right here. This is our jobs board, and if you jump over there, you can look for work. You can see people posting there with some full-time, part-time, contract, remote, in-person, freelance, all different types of jobs. And also there's the available for hire section where you can post your own resume. It's all entirely free to use, so go check out jobs.adafruit.com if you're looking for work. I mentioned I've got this right here. This is the show that I do on Tuesdays. That is the JP's product pick of the week. This week it was the Featherwing Tripler, and on the show I like to do a little bit of a demo. If it's a project that involves some code or a product that involves some code, I'll usually do a little bit of a code example. And this week it was mostly just hardware, because this is a simple one hardware-wise, but I love it. So here's a little 1-minute recap. Usually the show's around 10-15 minutes long, and you get a big discount during the show. So here it is. It is the Featherwing Tripler. Now this is great for tacking together a few different feathers a feather and a few different feather wings. It's also great for adding a little bit of an extra circuit, some input and things like that, and having a really convenient place to solder it. What I'll do is I'm going to take a feather and place that right in the middle there. And then I'm going to put a display on the top here. And then finally, I'm going to use this Joy feather wing on the bottom. So I've got these two feather wings, OLED feather wing, Joy feather wing. So if I go ahead and power this up, you can see it's as if we stacked those things, except you wouldn't really want to stack the joystick on top of the display or the display on top of the joystick. So I've got the joystick coordinates there, or if I'm pressing buttons, I can see those light up there. It is the Featherwing Tripler. Yes, indeed it is. That's what it is. I was just booting up this screen back here. Let me see, what's my input? Do I have a... I think I have an HDMI input coming from that right there. Is that plugged in? Let's find out. It's always a mystery with this one. These older TVs really like to take their time when you switch inputs and see if they can decode a signal. Yeah, look, CircuitPython and Lars, which is a nice segue into our CircuitPython parsec. Like I said, this week's is pre-recorded. Let's check it out. For the CircuitPython parsec today, I wanted to show another really helpful tool to use when you're developing in CircuitPython, and this is called Disco Tool by our community member Neradoc. Now, Disco Tool we can use from a shell, or in this case I'm using it inside of Adam's shell. What it does is it allows me to see what devices I have connected by name. When I usually want to get to a REPL, I'll use screen. Well, the problem is right now I have two devices connected. I don't know which one is which. I just see these unfriendly names. So I don't want to use screen here. Instead, I'm going to use Disco Tool. If I run Disco Tool, there we go. Disco Tool will show me all of the nice names of the devices connected. In fact, there's even one connected that doesn't have drive and a REPL showing up. That's the trinket over there for my camera switcher. But here you can see I've got this Circuit Playground Bluefruit and this QT Py M0, and they're showing up by nice names. Now, I don't even need to look at the ugly USB modem name there. Instead, I can simply say Disco Tool -N for name, and then a part of that nice name. So how about QT? That's now going to connect me up to this QT Py here, which is just printing something every time it runs through its loop, which is great. What I'm going to do now is Control T and Q, which quits, and now I can run Disco Tool, but this time say Bluefruit, or just a part of that. And this is connecting to, I'm going to reset this, this is connecting to a program that's running to tell the phone notifications to show up on my little Circuit Playground Bluefruit. Another thing you'll see that I did there, which is really cool, is I reset the device, it auto reconnects, which is not the case with screens. This is super helpful even just for your normal development process. And that is your CircuitPython parsec. Hey, all right. Another thing, and this will be our segue into the project, is I'm very excited because I have a little button board that's helping me switch my audio here. Let me pop in yeah, you can see it right here. So this is the project I'm going to be working on this week and talking about these great little switches here. Check this out. If I hit the first button, I said, you can't hear me anymore, because that is changing the tracks out of my broadcast software. So I can go to the little intro song and then back to audio. And one of the things I really like about it is so long as I use this interface instead of my computer and clicking on things with the mouse, then I can look down here and see what actual track am I using, or what input am I using. So that's one of the cool things about this particular kind of switch, is that I'm using it as a momentary switch. It is a momentary switch, but I can in code tell those little LEDs to do something useful for me. So in this case, if I look down and see that on the first input there, I know that it's muted. So I may get used to, if I use that enough, I may get used to that, and it could be a really helpful tool for keeping track of. For some reason, those nice red LEDs are a bit more noticeable than the little yellow box that I get in my software. So kind of a nice interface, kind of nice use for this type of switch. So let's talk about these. Let me jump into, okay, press button 4. It's not connected to anything. There you go. We could have it connected to something, and I'll show you some demos where I have a couple, 2, 3 other ways of using these that I think are pretty neat. So first of all, let's talk about these. So here's the product in the Adafruit store, and these are little sets of 3, little packs of 3 of these. Not a bad price, $4.50 for a pack of 3. So I got a couple packs of the blue ones so that I could do this for, and then I have some extras to do something else with, a couple extras to do something else with. And what I'm doing, I'll write a guide on using these in a really basic way. Maybe this project right here, maybe I'll do this up as a guide. And one of the reasons is just trying to figure out how to use these, what's the pin out on them. I haven't seen these out in the sort of maker world too much, but I have seen them in products for a long time. There's the original version of this that I recall is from the Roland 808 drum machine. And in fact, let me jump into a Chrome window here, and I'll show you. So if you look up Roland 808, Let's look at an image of that up close. So yeah, how about, sure, this Wikipedia one. So you can see here on the 808 there were these 16 steps. They were grouped into sets of 4 just with color to let you know each, essentially these are 16th notes, so you can see each little sort of quarter note section as its own grouping of color. And then they each had a little red LED poking through, so if you were asking the machine to edit or play the bass line, you could see which of those steps were in use for the bass drum. And then if you move down to the track for snares, track for hi-hats, congas, wood blocks, things like that, claps, famous claps, you can see at a glance which things are lit up, just like on the one that I have down here. So those have found their way into other drum machines and other consumer electronics over the years. It's a pretty cool kind of switch. And these are a really nice sort of modern version of that. They're a little smaller than the 808 ones. They're a little bigger than the modern ones that Roland uses on their boutique line. They have these little small recreations that do some modeling and circuitry of the analog. Those use some smaller switches. These are actually kind of a nice size that we have here. I got to be careful not to press the ones that I have connected, or I'll end up cutting my audio out. And if you look at the product page here, we have them in a bunch of colors. We don't have the orange necessary to recreate the 808, but I can dream. So maybe Lady 8 will be able to source those. But we do have the white, the red, and the yellow. So we're just missing that orange. We also got green, gray, black here. So you could find a lot of uses for these. If you look at the product page, you'll see here is the underside of the switch. So a few things to mention about this. First of all, this is not going to work in a breadboard or in a perma proto board that has vertically tied pins. And that is because the pairs of pins down at the bottom, let me see, here's a bigger image that I made. So after I poked around with this with a multimeter and figured where things are on this, I decided to make an image of it so we can tell. First of all, you have your LED there, and so the LED has negative marked on it. So you'll see in the molding there it says minus. That's the negative leg of the LED. So that'll let you know, even though they're cut the same length, that'll let you know how to wire that up. And you essentially want to give that close to 2 volts. So if you're using digital pins on a typical microcontroller at 3 volts, then you want to put a 1K resistor, 1K ohm resistor in line with either side of that, and then you can feed it a digital out. You could also PWM it if you wanted to adjust the brightness, but I'm using it just in a straight 3 volt out, then going through the 1K. Then there's essentially a normally open and a normally closed side of a switch there, and a common running along it. And you can actually pair up all these ones that I've lit up in white here, or illustrated in white. Those are essentially, you can send all those to ground if you want. The normally closed side and the normally open side of those, since they're in line vertically with their common side, means you can't put this into a typical breadboard. If you look here, this is my fritzing diagram of, oh, it doesn't want to route stuff, that's okay. Fritzing diagram of how I've arranged this, and I don't have a version of that made in fritzing yet. We may end up doing one, but here you can see I'm essentially simulating this with a pair of switches that are in line with each other vertically, and then we have the LED sort of flipped around so things are on the proper side when you flip the switch down. So looking down from the top, unlike that diagram that's from the bottom. And then to wire these up to my Pico, I'm just using one GPIO pin per LED, one GPIO pin per switch, and I'm using the normally open side of this. So from the top-down view, that's the left of the switch. So again, looking at this, you can see I've got that normally open there and a ground. And in order to put this together, that's why I'm using this. Let me go to a bigger down cam here. That's why I'm using this type of proto board, which is a grid, and nothing is presupposed here. Nothing is tied to to each other. In fact, let me grab a screwdriver and open that up, and you can see how that is connected. If only I hadn't stolen my Phillips bit. There it is. So I'm using a pair of these proto boards just so that I can have a nice flat surface to put it on. This is not a two proto board type of circuit. It's actually really simple. And either you could free wire it like I have, or you could design a little circuit board. I think I'm going to do that. I think I'll make a PCB either breakout or a little breakout for 4 of these of some kind. Let me unplug this now. So here you can see I've got the Pico just plugged into these headers. Word of warning, by the way, I didn't make this mistake, but since the Pico, unlike Feather, which has an uneven set of pins on either side, since the Pico has the same number of pins on both sides, you can totally insert it the wrong way. So don't do that. That could be bad, depending on what you've got wired up. So I designed this to have the USB coming out the left here. So I just have, if you look at this, let me hold that nice and still there, and so here you can see this is one switch right here. So this is the normally open side, and I'm running to a GPIO pin. So the normally open side of each of the 4 switches is going to GPIO pins. The grounds I have running, you can see a piece of wire running all the way across all of those common, and then the LED, let's see, I have a tiny thin piece of wire running straight down to this kind of little bar I made for myself for ground. And then here is each GPIO that's talking to the positive side of the LEDs going through a 1K resistor. And then this up here is the ground from the Pico going to my little sort of ground plane there. So that's the sort of hand wiring that you'll be facing right now with these switches until we make some sort of a little carrier board. But you can see with this plugged in, we get this up and running again. Okay, so when I start this out, let me, my current code just lights up all the LEDs. If I hit one of these, I'm going to switch my audio. Come back to this one. So I should have a different startup mode probably depending on which startup LED set, depending on which mode I'm in. So speaking of the modes, let me go to, this is the demo I showed on Show and Tell yesterday, and so what I'll do is I'm going to actually switch out the code running on here, get rid of the extra me there, and over here in Atom, I'm going to put this into MIDI mode, and this I should probably turn into a switch with like 0, 1, 2, 3, however many modes we have. I could also do some startup stuff or put a selector of some kind on the board, but right now it's just going to change it in code. So I'm going to say let's run this in MIDI mode. Hit save, and so what it's going to do now is reboot, and again I think I'm let's go look at, is this the VCV rack? Yeah, okay, so here's the app. This is what I was showing last night. So this is my favorite little modular synthesizer, virtual modular synthesizer here, VCV rack. And what I have are my Pico running CircuitPython. You see this little blue module here says Pico CircuitPython. This is a MIDI input that can then send out control voltage inside of the program. So I'm bringing in some MIDI CC messages that are essentially off and on. So I send a 0 on one of the CC channels, that's an off. I send a 127, that's an on. These don't need to be variable for how I'm using them, and that's simply to turn on and off these mute switches. So if you see this section right here, this module called mutes, as I press a button on my little step switches here, I get different drum channels coming in, or this little sort of siren bass line thing. So those are all in sync with each other. It's all playing, it's just running straight ahead. Some variation based on how I'm triggering the drums. And then I can cut parts in and out. So it's just a mute switch for different drum tracks here. The way this is set up, if you're interested, and this will carry through to kind of any of the virtual modular synths, or if you were doing this sort of thing with real modules and a MIDI to CV conversion off of the little Pico here. I have essentially a drum trigger. That's this one called Topograph, based on Mutable Instruments Grid, and that is sending out triggers when to pulse the drum to these three here: kick-all, snare, and hi-hat, and those are all sending their audio as well as the little bass line to this mutes. And then those are interrupted by these 4 buttons right here, and then it heads off to the mixer. So that's what allows me to say, hey, I want to turn on the snare, turn on the hi-hats, turn on my funky kick, and bring back the siren bass there. So you can imagine it would not take much, given the amount of GPIO that's available on the Pico, even without doing sort of multiplexing or anything fancy. We could easily do 8 of these, because we need 16 GPIO in order to do the LED and the switch. So 2 GPIO per switch until you start getting fancier than that. Could we do, I don't think we could do 16. We would need 32, and I think that's more GPIO than we get available here. But still kind of a neat way for what amounts to about a $4 microcontroller, a couple bucks in proto board and parts, and then about $5 for those 4 switches there. Make a pretty neat little UI to do MIDI stuff. We can also do, let me switch over to my other view here for a second. We can also do a couple of things with HID. So if you want to see how I was doing the audio stuff, that was simply running it in this Wirecast mode. And all that's doing when I press those, you can see it right here. If I press this 3rd button, it's just sending essentially shift 3, which happens to be the pound sign. So shift 1, shift 2, shift 3, shift 4 are what I chose to be my keyboard shortcuts that I send to Wirecast, which is my broadcast software. And then in Wirecast, I set those up as custom shortcuts to say, go to my clear layer, so no audio, you don't hear any audio here. There we go, and back to audio. Sorry, I said that before I was in the app. So the code for that is similar to any of our existing HID codes. So you can see here, what I'm doing with these switches is I'm saying, let's not even bother loading libraries that we don't need. So if it says I'm in MIDI mode, then we load up some MIDI stuff. If I'm either in my desktop switcher mode, which I'll show in a second over there on my laptop, or if I'm in Wirecast mode, then we'll load up these libraries here: USB HID, HID keyboard, and HID key code. The other setup here, and the little loops that we run through are for our switches. So I'm using GPIO 6, 7, 8, and 9. Sorry, I just got distracted by someone over in our chat. Shahin says, don't know how I got here, what the heck you're doing, but keep up the good work. Have a couple of beers on me. Cheers. Thanks. Your message came up in bright yellow, so it was hard to ignore. I don't know how that happened. So same thing for LED pins. I've set up those as GPI 2, 3, 4, and 5. This is a nice little chunk of code that I usually grab from, I think it's the debouncer setup section of the ToddBot tips and tricks, which I don't have a window up for Todd's right now. He could probably put that in the chat. But if you look over in my Learn, I have a Learn guide. If you look up ToddBot in our, so this tips and tricks section, if you look up inputs, there's setup for debouncing a button and is also set up for a list. And this is really helpful right here, this bit of code called set up and debounce a list of pins. I use that logic a whole lot when I want to set up a bunch of something. So it doesn't have to be debounced pins, doesn't even have to be inputs. In the case here, I'm doing it with outputs. Let me switch back to that right here. So that allows you to build an array, or a list, I should say, of something that you don't even know how many of them are going to be yet when you make the array or the list, and then we append to it as we build each of those objects using the same logic. So that's what's building up both my set of 4 LEDs and my set of 4 switches. If I'm in MIDI mode, I also set up I set up the MIDI object, I create the 4 CC numbers that I wanted to send out on. This could be any you want. And I set them all to false at first, which means we can toggle that state each time we press the button. We know if we're going to turn the LED on and send a 127, or if we're going to turn the LED off and send a 0. If we're in the desktop mode, then we set up the keyboard object using HID devices. And then I have, in this case, I'm using Control 1, Control 2, Control 3, Control 4. That on a Macintosh switches between your 4 desktops, 4 of your desktops if you're using desktop spaces. So that's how I have that set up right now. But this could be for anything you like. And the nice thing about this, I'll show the demo in a moment, is that it does not rely on you toggling through a list of things. I don't have to go through 4 of these to get back to the first one. This is a more discrete, hey, I'm just going to go to desktop 1, I'm going to desktop 4, 2, 3. So that's why I chose to do this one this way. And then my key map, I have this little list of lists here that gives me a name to print just for debugging purposes. And then what the HID command is that we're sending, in this case modifier or control plus 1, 2, 3, or 4. And then it's very similar if I'm in the Wirecast mode. In this case, it's shift. So with the modifier shift, 1, 2, 3, 4. That just happened to be an available set of modifiers for me to switch my audio on and off. You could also do this for, it's actually really going to be useful for me for the audio stuff, but you could do this for any of your switching between cameras. So you've seen me use my camera switchers over there before. You could use this to bring on graphics if you're using OBS or Wirecast or another broadcast software. Probably you could use it for some Twitch stuff if you're Twitch streaming, for some of the integrations they have with OBS. And then here's the actual logic of what happens in the main loop of the code. So we look at all the switches, do the debouncer update. That just says let's check each of the switches, see if anything has changed. If they've fallen, then that means, since I've got this normally open with a pull-up resistor, that means I've pressed it. If I'm in MIDI mode, let's do this. And this just says, okay, send out a MIDI message of 127 or 0 and light up or turn off the LED depending on our state that we're in. That's this MIDI state right here, true or false. And we flip it when we press it. And then in the desktop or the Wirecast mode, we just send out the appropriate key map that we defined earlier by doing keyboard send and then key map whatever the button is that we've pressed and the second item in that little list. Flip the LED off or on, and then I'm also printing here. So let's do let me do a switch over to the desk mode here, and I'll resave. So this is just resaving the CircuitPython right onto the drive there. You can see it reboots. Now I'll unplug it and let's head over to my laptop over there and plug it in. I might need to scramble to find the right cables. Let's see. In fact, actually, when I start over here, I might show a thing on the Steam Deck too, but let's start off with the laptop. Let's get that started up. And what do I need? I need a USB-C to micro, either cable or set of adapters. All right, good luck to me. Let's see, is this one? No, but closer. Okay, here's a micro to an A, and I've got so close to having the right cables here. Sorry about that. Let's see, hold on. Can we do it? I don't want to have to go into the... I thought I had one of my C to A cables here, and I'm coming up short. Oh, there it is. Okay, let's see if this works. So these, picked up some dirt there. These, if they work, are great because that goes USB-C to A, and then I have an A with micro B, which is what the Pico has on it. I kind of forgot that the Pico doesn't have some USB-C action, because then I could use a C to C cable. Let's see, it's about a, I don't know, 50% chance this will actually work. And sometimes that is because these things, believe it or not, even though they're USB-C, have a right and a wrong way to plug them in. Oh no, no, it's not going to work. Let's see if that's really plugged in. No, and let me just try that side. No! Horrible. I don't know why. Let's try all ports. In all orientations. No. Okay. Do I have any... let me see if I have another option. Let me see if this hub works. Well, it's on, but I'm not so sure I trust that it's... Yeah, I don't think that's sending data. Oh, bummer. Okay. Yeah, I don't think this is worth spending too much more time trying to get working. All this is just going to be the Control 1, Control 2, Control 3, Control 4. So you'll see the ability to jump to a specific desktop is what we can do when that's working, and we see which one we're on based on the lights. So that's one thing. Let's see, though. I should be able to... Oh, wait! I just realized I do have the cable I need. I have it right over here. All right, let's try one more time. And I'll zoom out a little bit in anticipation of this working amazingly. Let's see. So this is a proper USB B micro to USB-C. Hey, it lit up. That's a good sign. Yeah, okay. Thank goodness for having the right cable. So there you go. That's the setup there, running that code. That means I don't have to use swiping among desktops and hunting and searching to find the right one. I can just start to memorize things. If you like to use this sort of desktops approach, just memorize that, oh, you know, I've got my email over on desk 4. I've got Photoshop on desk 1. I've got Chrome over here, and I have the Queen's Jubilee. That's what this insane backdrop is from our London trip. I didn't see her. This was from the internet. But so that's just sending essentially these Control 1, 2, 3, and 4. You could, like I said, do more of these. You could have a huge row of them or stacks of them, depending on how you want to use that as a modifier. But love this, that it's going to give me an indicator with the LEDs of the current desk. It works really well. The other demo, what I'll do, actually, since this is plugged in over here, let me go to Chrome, or rather to Atom, and I'm gonna reopen the code.py that's sitting on there, and I'll change this to, actually, yeah, I'll change this to Wirecast mode. And the reason I'll do that is in this mode, it's just going to send my shift 1, 2, 3, and 4. Sorry, that's really tiny on there. So Wirecast mode true, that means that this will now send shift 1, 2, 3, and 4, which isn't going to do me any good right here, but those happen to be, as far as a lot of video games concerned, the same thing as pressing 1, 2, 3, 4. I could have it actually press 1, 2, 3, 4, but I didn't need to in this case. And the way I'm going to use that is on Wolfenstein 2 here, running on Steam Deck. This cable's a little short for this. Let me pop it underneath. So depending on how you're playing your game, you probably wouldn't use the external keys here and all of this stuff, but with a more traditional mouse keyboard setup, this was just the easiest game machine for me to grab and show. We can do switching of our items. So in this case, let's go back to singles. We can go between 4 of your primary weapons in this game, which is super dark. Oh my gosh, sorry. But you can see there, for things like grenades or items of whatever kind, you can have little quick selectors, especially for things like strategy games where you can have macros or chain together a whole group of things. Depending on the game, might be kind of a nice little way to swap around between things. So that's my son's save game on this. I'm not going to mess with it, or I'll totally... Hey, hey, hey. All right, let's fire off the guns. All right, I'll turn that back off. So anything really that's expecting USB HID is going to be pretty happy to get this plugged in, because the Pico just shows up as a USB HID keyboard device. Now, I mentioned... Oh, actually, before I go any further, I'm just going to pop open my Discord so that I can see if there's any questions or concerns as we go. This, by the way, will also work with iOS devices, Android devices. It doesn't just have to be a computer. So it can be more limited, especially on iOS, what keyboard shortcuts can do. But it's certainly possible to do things like trigger camera stuff, sound stuff. Makes it, make for a pretty decent audio control for sound playback in Spotify or something like that. Wanted to show off the little switches themselves a bit, and maybe I'll head over to the down shooter for that. Let me blow out this dust. So here's some of the little yellow ones here. Cute little switches. Got our little contacts there. I decided to take one apart, inspired by Toddbot, who'd pulled one apart to say, hey, yeah, if you want to switch out the LED, go ahead, because it's pretty standard 3, is that a 3 or a 5 millimeter? 5 millimeter, I think, LED. I don't know, maybe that's more like 3. So you basically can just pry the thing off. It has a couple little retention clips here on the back and here on the front. Lift those off. You can then pry off the rocker, which is what activates the little switch on the inside, little spring-loaded switch. And then, yeah, I think I'll take this over to the down shooter so you can see it better. But you can see, first of all, the LED just pulls right out. So long as you keep track of anode and cathode sides of that, you can replace the LED if you felt like it. I like the red one, so I'm going to leave them in there. And then when this is in place, there's a little stem that presses down on the switch mechanism. Let me click on that for a bit for you so you can hear the nice clicky action. I'll put it up to my microphone. So even without the plastic in place, we're getting a nice clicky click. And the reason is this is activated with a little spring. I'm gonna bring this over. I saw that Steve in the chat said I'm off my rocker. If we take a look here, a little down shooter, And let me get as close as it'll let me still focus on it. That's not bad. So even get a little closer without putting a shadow on it. And I'm going to boost that exposure. And I'm going to take that white balance a little more natural. There we go. So if you look, this is a really clever design. There is a spring that's captive connected to this little bar right here. Sorry, let me focus that again. And the spring provides a little bit of give as you're pressing down on the rocker. That's what's actually contacting the top of this black spring here, and then it essentially buckles or draws. See, it bends, 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 and then straightens down at the bottom. And that's what's flipping this metal leaf here between the normally closed and the normally open side. So the way I'm using it, I'm using on the normally open side. That's the contact that's being made there. So both of these two common legs remain in contact, and then we either break contact on the right side there, or we make contact on the left there. So really clever design, and I imagine it'll easily live up to the 80,000 clicks or whatever they mention on the data sheet. I'm sure many, many, many more than that. So cool mechanism, and then you can see here this is with the rocker in place, and that's where it contacts the spring right through that little hole there that's in the top of this piece. So you could certainly make the argument for using mechanical key switches, which give you a lot of options as far as keycaps go. Typically, if you want to light those up, you can either do a regular LED, a sort of old-fashioned mechanical keyboard style, or nowadays we can use RGB LEDs like NeoPixels and dot stars under there. But for simplicity, these are pretty nice. Once we make a footprint for it, it should be easy to add it into your designs. That's my hope, is to do a little fritzing object, and maybe we can do KiCad and Eagle if they don't exist. Maybe they exist already, but I'd like to make a little breakout of some kind. And let me know if you what you think of that. It might be worth doing one that's for our seesaw. So we could have an I²C that gives us the 4 button presses and the LEDs all on a chip, just like our, very similar to our Neo key, sort of 4 key breakout. Maybe we could do a spacing that works with 2 of them butted up against each other, so you could do a row 8 or a row 16. So that's it. Those are the cool little switches, and that's my project thus far. I will plug this back in and set it up to be my audio out. One thing I'd love to do, but tends to be challenging code-wise for me, is something like a sequencer, something where you could see maybe 8 or 16 steps where the LED is PWMing some little extra brightness to let you know where we are in a music pattern, drum pattern, that sort of thing, and then enable or disable steps per switch, which would be loads and loads of fun. So let me go back here, and I'll set this to Wirecast mode again. Oh, I think I'm already in that mode, aren't I? Yeah, we'll just be double sure. Yeah, we're not. Oh, I'm not plugged in. Well, that'll make it hard. Doesn't work when it's not plugged in. Let's not save that. Let's do, yeah, we're in Wirecast mode, okay. Save that. Good, all right, that'll be useful for the end of the show when I have to cut the audio, so get ready for it. Can you stand the drama? And let's see, anything else? Any other questions over... oh, okay, so Toddbot mentions you don't have to remove the middle part to replace the LED. That's good to know. I don't know, were you able to just push it up and out, or do you need to remove the lever? You might be able to just push it up and out. Let's see. Yeah, so if you just shove that out, up and out there you go. You can leave the whole switch assembled and get the LED in and out of there. You probably also choose your height. I didn't do this when I assembled this board, and I noticed some of these are slightly different heights than each other, so you could go in here, maybe lay something across the top like that, and start with it a little bit proud and press it down, or whatever you want. Get that to a consistent height before you go soldering it down, because then you won't be able to... Yeah, so no disassembly required to get the LED out, which is cool. Let's see, other questions? No? Can they be placed closer to each other? Yes. You can place them right up against each other. In fact, thanks for asking. That's a great question. If you're using one of these 0.1 inch space boards, there are two plastic pegs for alignment that you want to watch out. Make sure those have a hole to go into. So those are one row below the bottom contact. But these will go right next to each other, like so. So I think there's a single row between these two, so these essentially overlap by half a row. So these will go right next to each other, which, depending on your needs, great. You can pack a ton in. I think this spacing is fairly nice for not accidentally pressing neighbors. This one's a little close, depending on your precision in pressing. But yeah, you can get them really right up next to each other, which is pretty snazzy. Let's see, any other questions? Oh, I should pop up the Discord here. Johnny Bergdahl said, "You're late to the stream, please restart." I wish I could. Just rewind, or go watch the replay later. Yeah, Mouse said they'd like to have some blue LEDs in them. Go for it. Yeah. All right, that's going to do it. Hey, thanks everyone for stopping by. Go grab some of these switches. They're super cool. I'm excited to do some stuff with them. Give me any feedback over in Discord about what you'd like to see. If I do a breakout board or a little simple PCB that you can order, what you want to see on that. That's right, Steve. Be kind and rewind. All right. That's going to do it. I am getting ready to sign off. I'm also getting ready to hit these buttons and turn off my audio. Never been so excited about that. For Adafruit Industries, I'm John Park. This has been John Park's Workshop, and tune in tomorrow for a deep dive with Scott. Scott is back for a deep dive because Foamy Guy is out, so stop by and say hi, and then we'll be back next week with a whole slew of new shows. Thanks, everyone. Bye-bye.